We're just looking at calories and joules. And from looking at calories and joules, you found that the energy required to change the temperature of a substance depends on a couple of things, and we're going to add a third right here. First of all, the amount of the substance. The more grams of substance you have, the more energy it takes to raise it a certain temperature. Also, the temperature change you want to produce. The greater the temperature difference, the more energy you need. And there's a third piece when we're dealing with things that aren't just water, is that we have the substance's ability to absorb heat. This is what we call the specific heat capacity of a material. Now, different materials have different specific heat capacities that are kind of summarized over here. In fact, you can identify a material based on its specific heat capacity. It's a physical property just like density. How do we relate it all? Well, the energy required to change the temperature of something depends on the specific heat, its mass, and the amount of temperature difference. That's all three things you saw right here. Q represents the heat that's gained or lost, and the units for that are joules. S is the specific heat capacity in joules per gram degree C, which you could pick out of a table, or it'll probably be given to you in a problem. You're not expected to memorize all this stuff. M is going to be the mass of the material in grams. And delta T is the temperature change in degrees C. Now, delta T is going to be its final temperature minus the initial temperature, or the temperature you subtract the temperature it started at from the temperature it ended up at. Or T2 minus T1 is the way it's usually interpreted. Now, it's just like when you're doing slopes, got rise over run, or delta y over delta x, that equals y2 minus y1, or x2 minus x1. Well, delta t equals t2 minus t1. Let's do some problems. For example, what quantity of heat is required to heat a piece of iron that has a mass of 1.3 grams from 25 degrees C to 46 degrees C? Well, just like always, we get our givens out here on the side. So we read through the problem, we see number, 1.3 grams. 1.3 grams equals M. Since it's a gram, it's a mass, we're going to put an M in there. Next one, 25 degrees C. 25 degrees C. That's a temperature. I'm going to make that a big T, and since it's the temperature it started at, we're going to call it T1. Up to 46 degrees C. 46 degrees C, that's going to equal T, and it's the second temperature, so we're going to call it T2. Now, we also have to consider the specific heat of the material, which is what S represents. And since that's iron, we go back to our table and we find that it's 0.45 grams, joules per gram degree C. So we're writing 0.45 joules per gram degree C to represent S. Q is what we're looking for because it's asking us what quantity of heat. That's what we're asked to find. So the formula, Q equals SM delta T. The specific heat is 0.45 joules per gram degree C. We plug that in. M is mass. We put that in. Delta T is T2 minus T1. So here's T2, here's T1. We put them in here, T2 minus T1. We then look and cancel our units. Don't pick up the calculator until you make sure the units cancel to give you the one you want. Grams, cancel grams here. Degrees C, cancel degrees C here. And joules are left over. Now I know then if I work this out, chances are I'll get the right answer. But let's say I forgot to put in the mass. I just had the delta T and the energy. Well, I wouldn't have anything to cancel this G here, so I know that I'd be missing something. Oh yeah, the mass, and I'd write that in. So, always cancel the units before you do the math. And I find I get 12 joules. Hey, let's say I want to change it to calories. Well, 12 joules times 1 calorie per 4.184 joules allows me to cancel these J's out and leave me with calories, and I get 3.6 calories. Now, as long as you remember there's 4.184 joules in a calorie, you don't ever have to remember if you multiply or divide. You just arrange it the way that makes the unit you don't want cancel. and keep the one you're looking for behind. So, that's QsmaT. Here's some practice on your own. So you have a 5.63 gram piece of gold. It's heated from 21 to 32 degrees. How much energy is required? Now you can work this on your own. I'll even give you the answer. 8.1 joules or 1.9 calories. Go ahead. Pause the tape. Try it. I said pause. Pause it. Okay. Well, if you're watching this part, it's because you didn't get the answer. But, like before, we write all the givens off to the side. 5.63 grams. Oh, gram, that's a mass. I'm going to make that M. Oh, I got a temperature. Here's the starting temperature, 21 degrees C. That's T1. 32 degrees C. That's the temperature it goes to, so that's going to be T2. Write those off, and we need an S, because we got an M, we got a delta T. We're trying to find Q. We need to find an S to fit in there. So, since it's gold, we go back to the table. AU is 0.13 joules per gram degree C. So that represents our specific heat, or S. Then we go back to the formula, we plug all the numbers in. S is 0.13, M is 5.63, delta T is T2 minus T1, or 32 minus 21 degrees C. Then we cancel units, cancel. We're looking for heat, so we want joules left over. It's 8.1 joules. And then we can change it to calories by taking 8.1 and dividing 4.184. So calories over 4.184, multiply that out, becomes 1.9 calories. Now we got one more. This is really a practical application of heat. Let's say we have a piece of metal, 1.6 gram piece of metal that has the appearance of gold, but we don't know if it's gold. We do know, though, that it takes 5.8 joules of energy to change its temperature from 23 degrees C to 41 degrees C. Is the metal pure gold? Well, the answer is no. Maybe you can figure that out, how to find that. Because I said, specific heat capacity is a physical property of all materials. So you can identify something based on its specific heat. So I guess you're asking yourself, what's the specific heat of this piece of metal? Okay, pause it, figure it out. Well, let's get the answer. Because this is a specific heat is a physical property, we can identify it. That's really what we're looking for. What's the specific heat of this piece of metal? So we put the numbers that we know in. 1.3 grams, ooh, that's a mass. 1.6 grams, that's a mass. 5.8 joules of energy, that's a Q, because now we're getting Q this time. And we're being asked to find something else. T1, 23 degrees. T2, 41 degrees. I'll put those in. And so we're looking for the specific heat because that's the piece that we don't have. So we go to our formula, we plug in the numbers. Q is 5.8 joules. 5.8 joules. S, we don't know. That's still S. Mass, 1.6 grams. 1.6 grams. Delta T is T2 minus T1, or 41 minus 23 degrees C. We put that into the formula, and then we solve. Now to solve for this, we got to really divide both sides by 1.6 and 41 minus 23. So we set that all up over here, and then using our order of operations, we work out 41 minus 23, which is, what, 28 degrees C? No, it's like 18 degrees C. So then it's 5.8 divided by 1.6 divided by 18 gives you something other than 0.13 joules. So therefore, this can't be gold.